Welcome to a virtual GED class. We're continuing the topic of data analysis today, and we are just going to dig even deeper into the concept of mean, median, and mode, and range. Today, we're going to look at doing mean, median, mode, and range from probably the challenging for most students type of presentation of the data. Our data will be presented to us on a frequency table, which often confuses students. And so let's take a look. In order to know what we're going to do, we're actually going to look back a little bit and ask ourselves, do we remember? You're not going to be able to do this lesson unless you know what mean, median, mode, and range are, and unless you know what a frequency table is. So let's take a look. So first question, do you remember mean, median, mode, and range? So I don't have a frequency table yet. This time I still do just have a list of data. You guys can see it over here on the left. A group of students were asked how many hours they spend studying outside of class each day. The data is recorded below. So this time I just have a list of data here, and so this is what we're used to doing. So first question says, what is the mean number of hours these GED students spend studying each day? Someone remind me what a mean is.
The average.
Mean, absolutely, also known as average. It's what we would get if we all shared equally, if all the data was shared equally, or if all the students, for example, studied the exact same amount of time, which we know is not true. And anybody remember the method to find a mean or an average?
You find the total and divide?
Absolutely. You find the total of the data set, and then you divide by the number of items in the data set. Beautiful. So very simple for this particular problem. Now, you guys are going to have to forgive me because I'm too lazy. If I go to total this, I'm going to total it in my calculator, and I just have a list of data like this. How would I total all these numbers? Mathematically, what do we use to just total a list of numbers?
Addition.
Addition, absolutely. And so I'm too lazy to add zeros because I know they do jack, so I'm just going to skip over the zeros. I know when I add zero, nothing happens. So I'm going to go 1 plus 2 plus 1 plus 1. And you guys should do this in your TI-2 if you have yours, because I make mistakes. And I would rather you guys corrected me than the internet, as you know. Somehow it's less humbling. Probably because I can edit the videos. Okay, so I got a total here of, when I added these all up, 35. Now, the funniest thing always happens. I know that Shelby, I think it was Shelby, told me the process here of getting mean. We're supposed to total the data set and then divide, but too many students just stop right here and they forget to do the division. And I'm like, guys, you do not spend an average of 35 hours a day outside of class. We don't even have 35 hours in a day, so this wouldn't make sense anyway. So I'm going to go ahead and divide. Now, what should I divide by? Well, how many items were in the data set? Even though I didn't add in my zeros, they are still items in the data set, so make sure you count them. Looks like we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then another 12 makes 24, 36, 37, 38, 39, 40. So I am dividing by 40. Is everybody okay with that?
Yeah.
Now, I have a lot of students who now freak out and tell me, Kate, you cannot divide 35 by 40. 35 is smaller. I better change the order. No, that's not true. Your third grade teacher screwed you up and scarred you. It is possible to divide with the smaller number first, okay, guys? And so I get 0.875. Now let's consider if this number makes sense. The question we had asked is, what is the mean number of hours these GED students spend studying each day? Does it make sense to have about 0.8 hours, less than 1 hour? Yes, that's probably accurate. In fact, I'd be surprised if it was this high, to be honest, guys. But there you go. It would make sense for you to spend a little less than an hour each day outside of class studying. A lot of students are like, oh, I better round it. I don't like 3 decimal places. It's possible to have decimal places in hours. Don't worry about rounding it unless you're expressly asked to, or you have some other clue that would tell you to round. Okay, cool. So we remember mean. Excellent. Now, number 2, I hope somebody laughs at this. Number 2 says, what is the average number of hours these GED students spend studying each day? What is average? How do you find the average?
You add everything up and then divide it, what we just
You
did.
total and divide. Guys, mean and average are synonymous. I'm trying to trick you like it's not. I always do that. You better watch. I do it in every class.
Because I would have just blurted out everything.
So what's the average? Well, if the mean was 0.875, guess what? The average is 0.875. Same, those two words are absolutely and totally synonymous. Don't let the math teacher or the GED test trick you. So now we will move on to a new topic, though, I swear. Okay. So number 3 says, what is the median number of hours these GED students spend studying each day? Median. How do you find the median?
Don't you have to count from like the least to the most and then find it in the middle?
That is very good. The median is the middlemost number or the center of an ordered list. It has to be ordered. So I like how you said to put them in order first. Now, I'm a little resentful about putting all these numbers in order. I have to be perfectly frank with you because there are a lot of numbers. So I think that I'll just go counting first. I'm going to count all my zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 zeros. That's a lot of zeros. 10, 11. And if you're thinking, oh, my land, Kate, there's got to be a better way. There is. That's why we're doing class today. We're about to learn it. But for now, this is the only tool I have at my disposal. 14, 15, 16. What did I say I had? 17? Yeah, 17 zeros. Okay, we're done with the zeros. Now let's try the ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 ones. Is anybody's arm hurting in sympathy for me yet?
No.
Thanks a lot, James. 10, 11, 12, 13, 14. 14 ones. Okay, there's all my ones. Now how many twos do I have? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Dear goodness. And it looks like I have 1 3 and 1 4. I totally ran out of space. And this process is like taking me a while, isn't it? One off the front, one off the back, one off the front, one off the back, one off the front, one off the back, and so on and so forth until I finally reach the middle. Guys, I hope I'm convincing you right now that there has got to be a better way. I don't know how much scratch paper they're going to give you when you take your test, but I actually do know. They give you a dry erase board. If you take your test at Yavapai College anyway, you're getting a dry erase board. And did you guys know that you have to raise your hand to get your dry erase board erased? Serenity knows this. Okay, so I had 2 numbers in the middle, but guess what? They're both 1. So what's the median here? It's 1. Now, you could follow the process. You guys are like 2 in the middle. You told me, Kate, I must add them together and divide by 2. Okay, 1 plus 1 is 2, divided by 2 is 1. Okay, so I'm going to get 1 way or the other. The median number is 1. Did it take a while? Yeah. I told you guys already. I warned you. I saw a problem on the that a student sent me a clip of on the internet the other day. Can you help me with this? 1,000,000 items in the data set. I say good luck putting 1,000,000 items in order and finding the middle. Have fun. We need a better way. We're going to learn a better way today. Okay, I only had 40 and it made my arm hurt. We good with the median? Does that make sense, everybody?
Yep.
Yeah.
Okay, so then 4, what is the mode of the hours these GED students spend studying each day? What does mode mean?
The trend.
Most frequent number.
Trendy, that's right. And what did you say, Shelby?
Most frequent number.
Most
Yes.
frequent. It's trendy. It's most frequent. It comes up the most. The word mode even sounds like most. So what number came up the most? Well, it kind of helps you that I counted as I was writing them down. Anybody know which one of these numbers I put up there the most?
0.
0. Yeah, I had a bunch of zeros. And now 5 says, what is the range of hours these GED students spend studying each day? Someone remind me what a range is.
Is it the numbers in between, like 0 and 4?
Exactly. It's the span in between the highest and lowest number, or the difference between the highest and lowest number. And so we'll do that by subtracting. I'll take the larger number first. The largest number that we have in our data set is 4. That's the most hours anybody spends studying. And from it, I'll subtract the smallest number in our data set, which is 0. and I get a span of 4 hours, which makes sense. So next thing, do you remember how to organize data into a frequency table? So here's that exact same data. There it is. There's my group of students. I don't like the list of 40 numbers, and I would like it even less if it was 100 numbers. What if I asked 1,000 students? What if I asked 10,000 students? That would be one long, ugly list. And so one of the ways that we said we could organize data that had a lot of repetition, or even data that didn't have a lot of repetition, was in a frequency table. Okay, so in a frequency table, we need a column that has the data, and we need a column that has the frequency. They won't necessarily be titled that, but we need to have at least that much information. So the data that I'm looking at is what? What are these numbers here? What do they represent?
Hours.
Studying outside.
Hours of study, exactly. This number right here, 0, means 0 hours of study. Now, I like that you said students, but students here is the frequency. The number of students that answered 0 is the frequency of the answer 0. So I'm going to put in my frequency column, the title of that will be number of students. Does that make sense, how that's the data and how that's the frequency?
Yes.
Okay.
Yes.
And we only have a few possible answers for hour of study, so no need to use ranges. All I have here is 0, 1, 2, 3, or 4. And so I'll just, because I have such a limited amount of responses, I'll just list each one by itself. And now, of course, the frequency, the number of students, is just that counting I was doing earlier, and I forgot everything I counted, so let's do it one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 ones. 1, 2, 3, 4, 5, 6, 7 twos, a 3, and a 4. And because I screw things up all the dang time, I'm just going to make sure that my total matches. I was expecting 40 students. I should have a total of 40 in the frequency column. Let's make sure. 17 plus 14. It would suck to do all the hard math right and then get it wrong because you just like missed a number. And I did. My frequency did add up to 40. So I obviously have all my numbers. Good. This was a review. I'm glad it makes sense. Now let's get to the new stuff. Possibly one of the most challenging data analysis problems I know of for students. It's not actually that bad, but for some reason it blows our minds, okay? We've actually figured out the mean already of this data earlier. We found out that it was, I still have it in my calculator, 0.875. So we better, even if we have the data organized a different way, instead of being a list, it's in a frequency table, we better make sure that what we do here gives us the same answer. Since it's the same data, it ought to have the same mean regardless of how it's organized. This says find the mean using a frequency table, and we have a little bit of information here. It says the frequency table shows the number of hours a group of GED students spend studying outside of class each day. On average, how many hours do the students spend studying independently each day? A lot of people just come straight to this column and they go, look, there's the data. Those are the hours of independent study. And so then what they choose to do is just add up those numbers. They'll say, okay, I'm going to add 0 plus 1 plus 2 plus 3 plus 4, and they get that 10 total. And then they say, okay, now I'm going to divide by 5, because that's 5 numbers, 1, 2, 3, 4, 5. And they come up with this answer too. And yet before, our data had an answer of 0.875. How could it suddenly have a mean of 2 because it's organized in a different way? This answer doesn't make sense. Why? We've done some really bad thinking here if we just add up these numbers. What have we done? We've forgotten about the frequency. Frequency matters to the mean. You must account for repeated data. Okay, so I will just remind you, as Shelby told us earlier, the way you find the mean is you get the total of all the data, including the repeated ones. And then when you're done, you divide by the number of items in the data set. Now, that answer of 0, I didn't just have 1 0 in my data set. I had many zeros in my data set. How many zeros did I have in my data set?
17.
I had 17. I had 0, 17 times. And so when you go to find the total, you are just going to times the 0 and the 17. Why? Because frequency means number of times. And in math, when we want to find a total with repetition, we multiply, not add. And so I'm going to have to multiply. Now, of course, no matter how many times I times 0 by anything, I'm just going to get 0. So for that particular line, it was a little boring. But it gets a little more exciting here because I didn't just have the number 1 once. I had the number 1 14 times. I had 14 ones in my data set. That's not a total of 1. That's a total of
14.
14, exactly, James. How about my 7 twos? How much total hours of study is that?
14.
Exactly, another 14. And then my 1 student who said 3, that's just 3 hours. And of course, my 1 student who said 4, that's 4 hours. So I kind of have these like subtotals of each of the groups, but I want a grand total of all the groups together. So what should I do with these numbers I got?
Add.
I'll just go ahead and add. James is absolutely right. I got 35. Now this should look familiar. Does this number 35 hours look familiar? Yeah, that's what we got when we totaled the list by adding all the numbers before. So you can add a huge long list of numbers, or you can use multiplication to talk about the repetition and just add up the numbers at the end. But either way, we got that same answer of 35. And either way, we're not going to stop here. We're not going to stop here because all we've done is find the total of the data. If we want to find that average, we don't just total. Now we divvy it out evenly among all the items in the data set. But how many items are there in the data set? A lot of students tell me, well, there's 5. 1, 2, 3, 4, 5. Yeah, they're wrong. So how many items are there in the data set? Well, I had the first 17 zeros, so that's 17 items right there. And then I had 14 ones, so that's another 14 items in my data set. So now I have 17 and 14. Mathematically, what do I do if I have 17 and 14 and I want to put them together?
Add them.
Yeah, I'm just going to add. I'll add. I'm going to total my frequency column, 17 plus 14 plus 7. And we already know what that is because I did it earlier. The total of my frequency column is 40. So the number of items in your data set, write this down because this is what I think students forget. And this is really key. The number of items in the data set is going to be equal to the totals of the frequencies. So if I really want to find the mean, remember order is important. I'm going to start with the total of the data items. The total of the data items, we had 35 total hours the students spent studying. I'm going to use my unit with me because it helps students understand this better. And now I'm going to divide by the number of the items in the data set. Well, what was the number of items in the data set? It was my 40 students. Now, of course, we've already done 35 divided by 40. We did it on the first slide. We know it comes to 0.875, but I want you to notice something about the wording. The units, knowing the units up here will help me to know what this 0.875 represents. It represents hours. I stole my first unit. And divide can be signified with the word per. So 0.875 hours per student. Exactly right. And see how knowing those units and keeping track of those units can help you make sure you divide in the right order? Mm-hmm. I was looking for hours per student, not student per hour. That doesn't even make sense. Okay, so I think that it would be worth it for us, since I've seen students screw this up so much or forget it or panic on their test, to really sum up what we did here when we were looking at a frequency table. Okay, so first, when we found that total of the data, we multiplied the data by the frequency in each line, and then we added the results to get the grand total. Does that make sense?
Yes.
And then when we found that, we then did the second thing. We had to find the total number of items in the data set. We said the total frequency is the same as the number of items in the data set. So the number of items in the data set is equal to the total frequency. And then we were able to do the division where we divided the total data by the total frequency. So we divided number 1 by number 2. And you know what I mean by number 1 and number 2. I just mean the ones above right there. I don't want to rewrite it all out again. So I want this system to make sense to you, because if you just try to memorize it, like, oh, I'm going to memorize these 3 steps when it's a frequency table. There's too many different types of math problems on the GED to memorize everything. It does need to make sense to us, but this is a basic synopsis. I actually expect that if you have something like this, it'd be on the science or social studies test, although it's fair game for the math test as well. But they particularly favor data analysis on science and social studies. Another one that students find particularly challenging is finding the median using a frequency table. Remind me how we found the median when we just had a list of numbers?
You put the numbers in order?
And then we went to the middle. We put the numbers in order and we went to the middle. So here's what I'd like to say to you. These numbers are already in order, okay? Here I have all the zeros, all of them first. And then I have all the ones standing next in the column. And then I have all the twos, there they are, all the threes, and all the fours. Now, could I use my old-fashioned system of listing out all those numbers along the side of the paper like I've done before because I'm such a creature of habit? You could. But remember what a pain in the butt it was with 40 items in the data set. Imagine if I had a bigger table like that one with 1 million. You'd never be able to do it. So we need a better way. So since they're already in order, I won't worry about that part. So we know the first step is to order the numbers, but check they're in order. So the second step is just to locate the number in the middle. There's got to be a better way to locate the number in the middle than one off the front, one off the back, one off the front, one off the back. I mean, mathematically, how could we find the middle of a set? Like say we know we have 40 students standing in a row. Which student would be the middle student?
20.
20. 20. What'd you guys do mathematically? What are you doing? To 40 to get to 20 to think of the middle.
Divide by 2.
Dividing by 2. You're breaking that group right in half. You say divide them down the middle, that's breaking that group right in half. So I love that. So I've got 40 students. If I divide by 2, if I break them in half, that means I'm going to have 20 students standing over here, 20 students standing over there. The middle is going to be between about the 21st student. So we don't have to list out all the numbers. We just have to locate the 20 and 21st student. We just need to know that middle student. That's all we need. We don't need all the other students. So how are we going to find it? Well, it's pretty simple because guess what? I know what the first 17 students in line told me. The first 17 students in line were my slackers. They're not working outside of class. They're waiting for me to just feed the knowledge to them, you know, in class. And they're never getting their GEDs, but that's another story. Okay, so there's my guys who do those. They're standing there, all 17 of them. I need to get up to the 20th, 21st student. Well, the next 14 students all have a 1. So guess what? 17 plus 14, there are my first 31 students. I went past 20 and 21. 20 and 21 were in this group. 17, 18, 19, 20, and 21 were both 1s. There they were sitting there in 1s. The median of this group is 1. I just went and found who was the 21st student to hit the middle of that list. And that's what makes it possible to do those problems that might have 1 million. Because if it's 1 million students, you don't need to list out every student. You just have to find the one in the middle of 1 million, the 500,000th student. And you could do that pretty simply with your calculator. Let's just do a basic synopsis of how we did the median. First, we did check to make sure the list was in order. It was in order. If it's on a frequency table, it's going to be in order unless you had unless like a 3rd grader who didn't know much about frequency tables made it, okay? Because we're trying to organize the information on frequency tables. It's going to be in order, okay? So, you know, check, it'll probably already be in order. And then 2, just figure out who's in the middle. Divide by 2 to find the middle. Divide the frequency by 2. I have to be clear. And then go find that student. And you want to find that student's answer. It won't always be a student, so I'm going to say find that item in the data set. So check they're in order. Divide the frequency by 2 to find the middle item, not middle student, and then find that item in the data set. That is a really good way to approach finding the median in a frequency table. And makes you not have to list out all those numbers. Now this one makes me happy. It really does. This is easy. This is the kind of measure of central tendency that you want to do from a frequency table. Look what I'm finding this time. I'm finding the mode using a frequency table. I want to know what is the mode number of hours these students spent. Somebody remind me what mode means.
Trend.
It's trendy. It's common. Guess what it is? It's the most frequent item. Mode is directly related to frequency. No wonder it's easy on a frequency table. So what is the mode answer in my class? It's really easy to see off a frequency table. What is it? Which hours of independent study, because that's my data, happened the most?
0.
0. Maricela, how did you know that 0 happened the most times?
Because it was 17 students.
Exactly, it had the highest frequency. So the number with the highest frequency, or I should say the item with the highest frequency, is the mode. Of course it is. That's what mode means, most common, frequent. So what is the mode number of hours? The mode number of hours is 0. And I think then that our mean, median, and mode that we found are all matching from the first slide when we had this data organized a different way. Now I want you to find the range using a frequency table. And this one also throws students because they overcomplicate range when they look at a frequency table. So again, I have the same frequency table with my hours of independent study. This is my data items. Every answer I got to my question, how much time do you spend outside of class studying, was between 0 and 4. And then I have my frequency, which was my number of students who answered that way. And I want the range. Remind me what the range is.
The number in between the first and the last number.
Yeah, it's the span or the difference, the number in between. I get what you're saying there, but it's the span or the difference of the data, So you don't care. This doesn't matter. It's not the span or the range of the frequency. A lot of people start taking those numbers. I don't want those numbers. I want the data. The only data I had was 0, 1, 2, 3, and 4. So what's the lowest piece of data I had? 0. And what's the highest piece of data I had? 4. So I'm just going to have the highest data item minus the lowest data item. And because frequency doesn't matter to range, that frequency column just won't even come up. Of course, I have a range of 4 hours in the amount of time students spend studying a day. Is anybody mad at me?
No.
No.
Okay, shall we try some more complex examples? Like these weren't complex enough to see what tricks the GED might throw our way. You guys are all like, yes, please give us hard stuff. Okay, here we go. One of the saddest things to me is that I often cannot get students to focus on me or focus on my lecture that I'm trying to give because they say, Kate, I've done this before. I know mean, median, mode range. You guys always do mean, median, mode range. It's so easy. It's only easy when it's on a list of numbers. It's never a list of numbers on the GED, and you get it wrong. So pay attention to what they're asking you and what the data looks like. They love complexity on the GED. Serenity's nodding her head because she's taken it. She knows. They're not trying to give you easy problems. Okay, so let's take a look. We have a different frequency table this time, so let's just examine it to make sure we know what's going on. It says the table below shows the number of GED tests passed by student in a certain class. And we see this column with numbers of tests passed. And then we have a female column and a male column. So again, it's a frequency table. We have data and we have frequency, but it's a little bit more of a complex frequency table because we're comparing two different sets or two different groups of people. So the number of tests passed, is that a frequency or is that data items?
Data.
That is data items. That's our data. How many tests did you pass? They answered me 0, 1, 2, or 3. There's our data items. How about this column females? Is that a frequency or a data item?
Frequency.
That's a frequency. That's how often a female told me she chose that particular data item. Okay, and then same thing, of course, with the males column. That's also a frequency. It's a frequency of a different group of individuals. Number 1, I really like because you can make a decent guess based on this chart, but I'm also going to check my guess using the math because that's what I'm practicing today. So number 1 says, on average, which group has passed more tests, the males or the females? First, I'm just going to ask you to make a guess. What do you guys think? If when you look at the column of females and you look at the column of males, on average, who do you think has passed more tests?
Female.
Okay, so Maricela predicts that it's going to be females. Anybody else? Do we agree with Maricela or not?
Agree.
Agree? What's you guys' rationale? What are you looking at here that makes you think that it's probably the females? Besides just, we think we're clearly superior in every situation. Poor James, the only guy in the class. But besides our flawed logic, what do you see here in the table that makes you think that?
I see
The numbers.
Yeah, where do the numbers lie, or what kind of numbers give you those hints?
Like just the number of tests passed and then like where it just corresponds.
Okay, so this is our prediction. We think it's going to be females. Let's take a look and see if we're right. So first thing I'd like to do is find on average how many tests the males have passed. Let's do it. How could we find the average number of tests the males have passed? Well, first we need the total tests that all the males have passed. And if we're finding tests per male or tests per man, then we're going to per or divide it by the number of males. And that will give us the tests per male student. So how could we figure out the first number we need is the total test? The total test pass. Help me out. How could I figure that out? Total test passed by the males, of course, since we're looking at the males.
We'd add.
I will add, but not yet. First, I'm going to multiply to account for frequency. Does that make sense?
Yes.
Okay, so 11 males have passed 0 tests. So I'm going to do 0 times 11. And of course, nothing happens when I do 0 times 11, but I'm just for, the sake of me being clear, I'm going to do that. Do you understand where I got my 2 numbers from?
Yes.
Yes, that number 0 happened 11 times among the males. Okay, what's the next row, or what's the next computation I'm going to do to find this total?
1 times 6.
I just heard 1.
Times 6.
Times 6. Exactly. 6 males gave me an answer of 1. That's a total of 6 tests passed between them. And then next row will be 2 males have passed 2 tests for a total of 4 tests among those gentlemen. And then 7 males have passed 3 tests for a total of 21 tests among those gentlemen. And now I can add to find my grand total of all the males' tests. So there were 0, of course, among the ones who'd taken 0, 6 among the ones who'd taken 1, 4 among the ones who'd taken 2, and 21 among the ones who'd taken 3. And I have a total of 31 tests among the gentlemen. Now, don't be the foolish student who gets so excited that they found a total that they stop right there and tells me the gentlemen have passed an average of 31 tests. I'm like, what tests are you taking? I'm so glad there's not 31 subjects on the GED. Okay, this answer doesn't make sense yet. Why? What do I still need to do?
And the number of students and the male.
Yeah, the number of male students. Exactly. I've got to divide by the number of male students. So let me count them out up first. So here's all my male students. That's 11 plus 6 plus 2 plus 7. That's 26 male students. So I'm going to take those 31 tests. I'm going to divvy them up equally between the 26 males. And guys, I just have to warn you that just like in real life, the data is not going to be super pretty here when we divide. That's okay. We'll just round it. Okay, so 31 tests divided by 26 males, and I get this really long, ugly decimal. If this were on the GED, it would probably have rounding directions or else a multiple choice, so you would know where to round to. But I'm just going to round to the 10th place. It says 1.1923, yada, yada, yada. I'll just take 1 decimal place and call that about 1.2. And then again, that's tests per male. Okay, so we're testing our prediction here, 1.2 tests per male. Now let us go ahead and deal with the females. And I sure hope my rounding doesn't make it confusing or I'll end up with rounding regret. Okay, so same basic idea. If I want to find the average number of students that the average number of tests that the females have passed, then I'm going to need the total number of tests by the females divided by the number of females. How could I figure out how many total number of tests were passed by the females?
We multiply the number of tests passed by the females.
Absolutely. 0 tests passed by 9 females. That's 0 tests among those first 9 ladies. 1 test passed by 5. That's 5 total among those 5 ladies. And then what would my next row say?
2 times 3.
Exactly. 2 times 3. 3 women had passed 2 tests. That's a total of 6 tests among them. And then our 3 times our 9. Our 3 tests passed by 9 different females for a total of 27 tests. Now what? I'm going to add those all up. I need the grand total. 0 won't do anything. I'm too lazy to even type it. 5 plus 6 plus 27 equals 38. We have a total of 38 tests passed among the females. But I don't want to know total. I want to know average. And so I'm going to have to divide that, and I want to divvy it out per female, so I'm going to have to divide it by the number of females. And here are all my females. So sorry for that technical error. We lost our screen for a second, but we're back. So we were comparing, on average, which group has passed more tests, the males or the females. So when we did our males, what did we figure out? 1.2 tests per male. And we had just found the total tests taken by all the women. Guys, how many total tests have been taken by all the females in the class?
38.
38 tests. Now, I've got 38 tests, and so I need to, if I want to do it, how many were per female? I'm going to have to divide or per it by the number of females. Okay, so let's do that. How many females were in the class? We were just trying to figure that out when everything went wrong, so let's figure it out. If I've got 9 who said 0, plus the 5 who said 1, plus the 3 who said 2, and the 9 who said 3, I would get 26 females in the class. So I'm going to take those 38 tests, divide it by those 26 females, and that will give me the test per female. 38 tests divided by 26 females, and I'm seeing that the females have passed 1.46, yada, 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 tests. If I were to round that, we're looking at about 1.5 tests per female. What do you make of your prediction? Did it turn out? Were you guys right?
Yes.
Yeah, you were right. So if the question was just like that on the test, on average, which group has passed more tests, the males or the females? I probably would have gone with my gut, checked that answer, and then if I had time at the end of my test, come back to check if it really numerically worked out, because you only have so much time on your test, and that was a complex problem. I do have this question, though. This one's a little more specific. Look at what this says. How many more tests have they passed on average? Now, they're not giving me wiggle room here. I need a number. How many more tests have they passed on average? Mathematically, how do you find how many more? We talked about this last class. Anybody remember?
You subtract?
You subtract. Exactly. How many more, how many less? We're talking about the difference between two numbers we're going to subtract. Now, guys, I know we have rounded numbers that we worked with, but it is always best to use your non-rounded numbers for accuracy. Round at the end. Do computations with non-rounded numbers. So, but the good news is my TI stored those numbers. I don't have to go redo them. I could just pick them up. So I can go, I arrowed over my last number, my 1.4. I arrowed up to it and I press enter and it appears back on my screen. And then I can arrow up to the number before that, the unrounded number of females. And press, it doesn't matter how high up it is. Your TI stores hundreds of calculations. Arrow up. And I get over that number and press enter. And they both appeared in my screen and I did not have to type them. And I think, though, that I forgot to press minus. So let's try it again. So if you could be like me. Okay, so I arrow over the 1.46. I actually press minus this time. And now I arrow over the other number that I want. Press enter on that one. And there, I got a difference of 0.2692. And I don't know what they want me to round to again. If it was on the GED, they would specify. But, you know, that's about a 0.3 difference. But if they had me round to 2 digits, it'd be 0.27. So we are good to go. But unrounded numbers for calculation. So we have a difference of, you know, a little less than, not even a half of a test. So pretty close. Number 2 says, what is the mode number of tests passed per female? The mode number of tests for the females. Okay, so somebody remind me what mode means.
Most common.
Most common. So for the females, what is the most common number of tests passed?
3. I mean 9.
You say 3. Maricela, you said 3 because it has a frequency of 9?
Yeah.
And I say, like, kind of, but there's another number with a frequency of 9, isn't there?
Yeah.
What's the other number that has that same frequency?
0.
0. So we have 2 numbers tied for first place. Anybody remember what we do with mode when we have 2 numbers tied for the highest frequency? With mode, you can actually have a set that is bimodal. And that's I always make the bad joke when I talk about bimodal so that you guys remember what bi means. But what does bi mean?
Like 2?
Oh.
2. A bicycle has 2 wheels and a bisexual loves 2 sexes. Okay, bi means 2. It's common prefix in our language. So if I say it's bimodal, what am I saying? It has
There's 2 of them.
2 modes. Totally legit answer. So what is the mode number of tests passed per female? I have 2 totally legit answers. I will separate my totally legit answers with a comma. It is both 0 and 3, and that can happen. Tricky. I'm a brat. I was meaning to do that too. You know how I am. Let's look at number 3. What is the median? So median, middle of an ordered set. What is the median, the middle of an ordered set? Number of tests passed for the males. So I'm only looking at the males. So let's just scribble out this. This won't matter to me at all. So what is the median? I'm looking for number of tests passed. I'm looking for one of the number of tests passed, but by the males. So in order to find the median number of tests passed by the males, I got to find the middle guy. I gotta find the middle guy. Now they're all standing in order already. First I have my guys with zeros, then my ones, then my two. They're already in order. I won't worry about putting them in order. Whoever did the frequency table for me already did that work. Thank you very much. But I gotta find the middle guy. Any ideas how to find the middle guy without listing out all these flipping numbers?
So we added,
What did you want to add, Maricela?
I don't know if we add 6, 2, and 7, or we do have to ask the 11 too.
I am. I'm going to add those up to find out how many males I have. Absolutely. So I'm going to add all those guys, 11, 6, 2, 7, and I find out there's 26 males. So if I have 26 males standing in a row, who's in the middle?
We divided by 2.
Divided by 2. Brilliant. The middle guy will be right between the 13 and the 14th guy, because I'll have 13 on one side and 13 on the other. So very nice, yes. So I need to find my 13th, 14th guy. Okay, they're usually the same in problems like this, so that's why I'm kind of shaking my hand like that. They don't make them that tricky. But I'm looking for my 13th, 14th guy. Where's he standing? Well, my first 11 guys all had a 0. So now my next few guys, my 12th, 13th, 14th, 15th, 16th, and 17th, the next 6 guys are those in those positions all have the number
1.
1. And so the median number, the median number of tests passed for the males is 1 test. I didn't have to find all the guys. I just had to find the middle guy and where he was at. Okay, so we still have one more problem on this page. It says, what is the range of tests passed per student for the class sample? The range of tests passed per student. So if I'm finding the range of tests passed per student, I need the highest number of tests passed per student. What is that?
3.
3, exactly. So I come to my number of tests passed column and look in the highest number. The highest number of tests passed is 3. Cool, that's tricky because we don't know where to get our numbers from. So then what is my lowest number of tests passed?
0.
0, exactly. When I'm doing the range, all I care about is the data. I don't care about frequency. It doesn't apply to range. So there's my 3 and there's my 0. 3 minus 0, of course, is 3. That's a really simple range. Can you see how understanding a frequency table will make it easier to remember where to look? Because, yeah, it's not a list of numbers. That's not what a frequency table is. So it can't be treated like a list of numbers. The table below shows the age ranges of 52 students enrolled in a certain GED program. Now this time, my data is not specific. My data is just in a range. So you can see here that I know that there's 25 students in that range, but I don't know if there's 16, 17, 18, 19, it could be 25 19-year-olds. It could be 24 16-year-olds and 1 18-year-old. I don't know anything specific about the data. I just know the range of it. I have 13 in their 20s and 7 students in their 30s, 5 in their 40s, and a couple in their 50s. Okay, and so I don't have a lot of specifics with this, which means that using your usual mean, median, mode type strategies would be really tricky because I don't know what the individual numbers are. But I can make some really good guesses based on what I do know. So let's look at this example. It says, which of the following, notice this language, guys, could be the median age of the students? Could be. I can't tell exactly, but I could tell kind of about what it might be. And you can see that it's a multiple choice question. It would have to be a multiple choice question because I can't find the exact answer because of this ranges, but I can make a guess. So we are looking for median. Remind me what a median is one more time.
In the middle.
The middle of an ordered set. Okay, so we got to check that they're in order. Are my people standing in order? Yeah, they are. The smallest age range is first, then the next largest, they're in order. Check, they're in order. I just got to find the middle of that ordered set. So now the hard question, which students in the middle? Which students in the middle? Help me figure that out. Anybody remember how we found out which student was in the middle? Well, let's start here. How many students are there?
52.
There are 52, Serenity. Where'd you get that number?
At the top of the problem.
At the top. Serenity's like, I read the directions because I've done one-on-one with Kate enough times. I know I got to read that. I got to read that. Hey, if I didn't notice that 52 up there, how else could I have gotten the 52?
At the number of students.
At the number of students. Those frequencies better add up to 52, or whoever wrote my problem is a liar. Let's see, 25 plus 13 plus 7 plus 5 plus 2. I wrote the problem, so if I'm a liar, I just got to retire. Okay, wonderful. So yeah, there's 52 students either way you look at it, whether you read or you compute the frequency. So if there's 52 students standing in a row, who's in the middle? About the 26th, 27th student. Exactly. I'd have 26 over here, 26 over there. So right between my 26th, 27th student is who I'm looking for. So my 26th, 27th student falls in what age range?
About 20, 29 range.
20 to 29, exactly. First 25 students in a row, right there are in that age range, but starting 26, 27 would both fall here. In my next group of 13 students. And so 20 to 29, and it's just purely a coincidence that it's always been the second row this video, guys. It didn't have to be the second row every time, okay? And I find that they would have to fall in the 20 to 29 age range. Now, that's not my answers. My answers have specific numbers. Oh my gosh, what am I going to do? Don't lose your head. Only one of these numbers fits in that range, guys. It's got to be what? Which of these could be the median, not must be the median?
28.
It falls in the age range. That's the only possibility in this list. And you see how having a frequency table, not even just having a frequency table, honestly, it's having your data organized differently than you were expecting. Having your data organized differently than you're expecting can change what you think of as the algorithm, the step-by-step that I have memorized. So it's really important to think about what these numbers mean, okay? So this won't be the only time we're gonna mix things up on you. After we finish all our different types of charts and graphs, we'll look at mean, median, mode, range off of all the different kinds of charts and graphs. And see how can I help you by giving you data in forms. Because like I said, I've never seen a single simple problem on the GED yet. They're usually complex. They like to mix word problems with charts and graphs, with data analysis or algebra or geometry. They like a mix of skills in the same question. Okay, so we can't look at these things isolated from each other. Thank you so much for coming to class today. It was really great having you guys here. And I think I feel back on my game. You guys were on your game. Good class. I won't have to edit too much. I'll see you next class when we actually dip our toes into the world of percentages. Again, a concept that comes up on science, social studies, or the math test. Fair game on all three. See you later, guys.